there's a wealth of laboratory evidence that these anti-tumor properties kill cancer cells in a variety of ways. There are multiple mechanisms of action identified by which cannabis kills cancer cells, and they're divided into various categories. And among these are anti-proliferative effects. Normally, that's one of the hallmarks of a cancer cell, is that it just keeps reproducing. So if you stop the reproduction, that's an anti-proliferative effect. There are anti-angiogenesis effects, and this means that the cannabinoids will stop the tumor from being able to elaborate or grow new blood vessels to support the growth of the tumor. There are anti-metastatic effects, and that is simple enough to mean that the cannabinoids block the ability of the cancer cells to spread into other tissues. And there's another effect that has a wild name, apoptotic effect. Apoptosis refers to the ability of cannabinoids to speed the death of the abnormal cells. That's something that is especially important in cancer, because you're able to hasten the death of the cell without disturbing the normal cells around it.
Seth Research Laboratories in California have recently demonstrated that in some tumors, cancer cells are killed by marijuana, while the other healthy cells are left untouched. Cells that stop moving and become still white dots are dead cancer cells. The ability of cannabinoids to kill bad cells while protecting healthy ones is particularly important when we're talking about brain cancer because of the so-called blood-brain barrier. The brain has to be sheltered from outside influences that might hitch a ride on the bloodstream and cause havoc. What is exciting and unique about cannabinoids is that they can pass through the blood-brain barrier because of their slippery, fat-loving nature. Cannabinoids get right into the brain's cancer cells by moving easily through the cell's membranes, which are also composed of lipids.
As the primary active constituent of the medicinal plant cannabis, also known as marijuana, most people are familiar with the euphoric effects of this compound. After entering the bloodstream, this compound becomes available to individual cells in the brain. Delta-9 THC interacts with specific cell surface receptors. It is analogous to a key entering a lock. This triggers a reaction inside the cell. Unexpectedly, this reaction in normal cells is significantly different compared to the reaction in cancer cells. In cancer cells, these reactions lead to cell death. In normal cells, it doesn't. This surprising difference is likely due to two things: a greater number of receptors on the outside of the cancer cells, and a different type of reaction inside the cancer cells as compared to the normal cells.
For Dr. Nayagar-Katti, the research has gone far beyond treating inflammatory problems. He's narrowing in on the potential of cannabinoids to kill immune cells that have mutated and become cancerous. Once they become cancerous, they no longer die a normal cell death. Instead, they begin growing and spreading uncontrollably.
We were one of the first labs to demonstrate basically that not only the immune cells, the normal immune cells express these cannabinoid receptors called the CB2 receptors, but also that when these immune cells get transformed and they become cancer, to our surprise, we found that these cancer cells continue to express these CB2 receptors.
This was an exciting discovery because the CB2 receptor can act like a target for the cannabinoids. Once they bind with the receptor, they can tell the cancer cell to die.
So basically telling the cells basically to commit suicide, and that's what they do. And we demonstrated that that would be the mechanism by which the cannabinoids can kill the cancer, and therefore it can be used effectively as an anti-cancer agent.
Dr. Nayagar-Katti and his researchers were able to eradicate almost 100% of the cancer in test tubes. but they were skeptical they would see similar results when they moved on to tumors in mice.
To our surprise, we found that almost 25 to 30% of the mice completely rejected the tumor. They were completely cured. And in addition, we found that the remaining mice also, there was a significant reduction in the volume or the size of the tumors as well.